Hello to everybody. My name is Fabio Masi. I'm working in an engineering and consultancy company located in Florence, Italy, called Iridra. We are working since more than 25 years with the design of nature-based solutions for water pollution control. This day, I am just going to present some real-scale applications of living walls and green facades for recycling grey water. The topic is a part of the circular economy approaches for a sustainable water management in urban settlements. As you can see in this slide, we can have different kind of installations, like for instance, rooftop wetlands, then the vertical walls, and even some ground installations like constructed wetlands realized in the ground. By these kind of approaches, recycling the grey water, every family can easily save about the 50% or even more of the water bill since the few days after the installation. How green wall for treating the grey water is working. This kind of installation is a pot-based one, which is meaning that we are just hanging to the wall some plastic pots which are then filled with some growing medium. We will see more details in the next slides. We are distributing the water by a regulated drip line, which is staying on top of a series of pots through where the water is just flowing and then is collected in a final gutter. Here, for instance, we have two series of 4 pots, which are where the water is percolating, and there are the 2 gutters, which are then bringing the water to a final reservoir where a submergent pump will redistribute the water in the following steps. The plants are creating by their roots a good location for the development of bacterial communities, and they are also playing some aesthetic roles, and they are even creating biodiversity by their insertion themselves, but even calling some insects like the pollinators, for instance, which are then creating other kind of biodiversity. The modular pots can be hanged to specific panels, and in this way we can even improve the thermal efficiency of this kind of addition to the walls, which are even slowing down the aging of the wall itself or the plasterer that is covering it. There are some others which are directly hanged to the wall itself, or we can even build a sort of grid where to hang everything in order to have a self-standing structure. The biofilm, which is growing inside the pots, just covering all the filtering material, is the main actor which is removing about the 90% of the pollutants, like it is happening in the constructed wetlands. The plants are selected in order to be tolerating in a good way the grey water chemical composition. They have to tolerate the humidity because these pots are fed several times per day, so the filling material is very humid, and these plants have to resist to this kind of humidity. And we have to consider that in the pots we have limited space for the root development, both in height and in volume. And obviously, the selection of the plants is a lot related to the aesthetic appearance, but also to the resistance, the tolerance to the sunlight exposition, which is then depending by the position of the green wall itself on one of the facades of the building. The growing medium instead has mainly to respect some mechanical characteristics. It must be very light and it must be porous in order to favor the biofilm formation with the highest surface that is possible to get. And it must be light because obviously you are interfering with the structural capacities of the wall itself. So, and this structural capacity must be tested before the installation. And for instance, if we could use only sand, which is obviously a very good filtering material and a very good media also for the biofilm development, the pots could be really too much heavy. And in most cases, then we are using this kind of material, which is an expanded clay aggregate. But using this alone could have the water flushing too fast inside the pots, and so we are mixing coconut fibers or other vegetable materials, steel fibers, for slowing down the flux of the water and giving it long enough retention time inside the system for having then good performances in terms of pollutants transformation. The first case, we called it a sort of commercial branding wall to water. It's a system that we have installed in a school in a small village in Sicily called Ferla. That's the drawing of the detailed design, and that's a picture of the installed wall. You see here that this green wall is aesthetically appealing and is treating the water from the wash basins of the school. It's a primary school, so little kids. The water is reused then for flushing the toilets, and this is amounting at about 1/4 of the total consumption of the school itself. The green wall is installed on 3 facades. Here you see just one of them, the central one, the one that is shown here in this part. But on the side here and the side on the other part, we have still these other units installed. Why? To install it on 3 facades, just for testing the different kind of the different effects of the exposition to the sunlight, depending by the location. So this installation is treating about 1.3 cubic meters per day for a total amount of about 260 cubic meter in 1 year. And this is giving as a result that each student is saving about 1 cubic meter in 1 year, just reusing this treated greywater for flushing the toilets. The total surface of this installation is about 30 square meters, and the design has been made in order to facilitate at the maximum level the maintenance, and so that's determining the height of the installation, which is not so tall as you can see, just because we wanted to make it accessible by not skilled personnel by a simple ladder. A second installation is instead the one that is in the Faculty of Agriculture in the center of Tunis, so we are in Tunisia. Here the greywater is produced by 2 buildings in the campus where the wash basin and the showers are segregated. And so all this greywater is then treated in this quite big green wall, and the treated greywater, so the effluents, are then reused for toilet flushing in the same building and for irrigating the green areas of the campus during the dry summer months. In total, we have 3 independent living walls for a total surface of 70 square meters. The treated flow in this case is about 2 cubic meters per day for a total of about 700 cubic meters per year. And those are some pictures of the installations. Here we created a sort of co-design process working with a local architect and making interviews with the stakeholders, mainly the students which are populating the campus. And the aim was to create an external open space where the students can spend time in a quite nice green environment with a lot of biodiversity and nice flowers and colors. The third installation is instead in Beirut. It's the American University of Beirut. Also here, the Greywater is produced in a guest house of the students, still coming from wash basin and showers. The total surface here is about 80 square meters, and the treated volume is still about 2.1 cubic meters per day for a total of 560 cubic meters per year. The water is totally reused for toilet flushing, and if some water will still be available in summer, that it will be used for external irrigation. Here, for instance, the architects, we worked together in the co-design phase, decided to go more for aesthetic values than for the practicity of the operation and management. And what you can see here is that the installation is much higher in comparison to the one of Sicily. This will make the maintenance a bit more complex, and some more specialized gardeners will work on it for the maintenance of the vegetations along the years. In this installation in Lebanon, we also are testing another kind of greywater treatment, which is ground-based. What you see here is a green facade, where we are reproducing exactly the mechanism which are happening in a vertical flow constructed wetland. So substantially you have a pocket of sand where the bacteria are then processing the different pollutants, and this very long and narrow vertical flow constructed wetland is planted with some climbing plants, and then we are providing just a support like a metal grid where the plants can climb up, creating the green facade. So on one side we have the green facade, on the other we have the green wall, which is installed over here. What we do in terms of testing is just to consider, for instance, different filling materials. One of the main weak points of this kind of installation is still the cost of the pots, which are plastic-based, and also the filling materials, so these clay, light aggregates of clay, of expanded clay. And so we are trying to find other alternative materials that can have the same mechanical characteristics, but being much cheaper. And that's one of the purposes of research for these three installations, which are all in universities in Sicily, in Lebanon, and Tunisia. And then obviously we are measuring the quantity of water before and after the treatment in order to understand how much we are going to lose by evaporation and evapotranspiration, and how much water we are able to collect for then reusing it. Clearly, we are monitoring the quality of the water in the inlet and in the effluent in order to understand how much high are the removal rates for the main pollutants, which are mainly the organic matter expressed as COD and BOD5, and the suspended solids. All this has obviously to fit with the local regulations for the reuse. We are also working measuring the temperature effects, both in terms of exposition of the pots to the different sunlight exposition, but even measuring the temperature in outside and inside the building for understanding what's the insulating capacity of this kind of wall installations. And those are some preliminary results where we have seen that in the three exposed surfaces, one is southwest, northwest, and northeast, we have the lowest temperature in the northeast facades, where the temperature can be like 6-8 degrees lower in comparison to the northwest and the southwest facades. That can be useful exactly when you get very high temperature values that could make the water going too high in temperature and then boiling the roots of the plants and then destroying your installation. We have measured some biodiversity. You see here a lot of pollinators, which are then creating biodiversity by themselves. We do a lot of education events, mainly with the little students of the school in Sicily, but also in the other two university installations with the university students. We have created some websites and even a short movie, which has participated to a lot of festivals of short movies, getting even some awards. We have now some first indications about the design of this kind of systems, and we can see, for instance, comparing with another installations done in Belgium, where the feeding is very low, like 40 liters per square meter per day, but there is almost zero discharge. So we are not producing effluents, but you are creating instead a biodiverse and a green facade. And that's quite different from the 300 liters per square meter per day that we are giving to the first row of the pots in our installations. And with this kind of hydraulic loading rate, we are instead creating quite a lot of effluents, which are then ready to be reused. Just to show that there are some other installations which are much cheaper in comparison to the green walls. I'm showing this one, which is published already in this book here. That's an installation done in the College of Engineering of Pune in India. And there is a constructed wetland, a vertical flow constructed wetland treating the Greywater. And that's a very well working business model, which is completely paying off the operation and management cost and even providing a quite fast payback time in the terms of about less than 10 years. And another installation is in Palestine. Even here we are treating the Greywater for then acting against the desertification. And finally, a green roof, a rooftop wetland or biofilter, which is installed in a park in the Serengeti park in Tanzania. Still, this one is created by the scratch, and that's the main advantage of working with the architects since the very preliminary phases, even because when you are instead working on existing building, the installation of this kind of rooftop wetlands can be quite difficult for the static properties of the building itself. So treating Greywater is a very good thing because Greywater is about the 70% of what you are able to treat in a building. And there are some good aspects related to the segregation of the Greywater from the black one. Because it's much easier in the biodegradation, and so you can treat it in a much faster way than if you mix the Greywater with the black water. Doing this, you are even reducing the water which is going to the sewer, and that's obviously saving a lot in terms of the power used for moving the water around the city and also for treating it at the end of the pipe. The bad aspects are related to still the very high cost of these kind of installations on the walls and the roofs if you compare them to the ground installations. Another bad aspect is that a lot of national regulations are permitting to reuse the grey water only for toilet flushing. And so toilet flushing is about 30% of the water consumption in a house. If you are treating the 70% and then able to reuse only the 30%, that's giving you a lot of excess water that you are treating for not then being properly reused. With this, I'm at the end of my presentation, and I thank you for your attention.